welcome Staff Developer Advocate, Confluent, Danica Fine.
Good morning and welcome to day 2 of Current. How are we all feeling? All right. And we enjoyed that party last night, right? Awesome. I, for one, am thrilled to be here kicking off another day of technical breakout sessions, of networking, and maybe, just maybe, a little bit of swag from the Expo Hall floor. It's tradition, after all, right? As Program Committee Chair of Current this year, I am so incredibly proud of the countless hours and hard work that our Program Committee has invested into making this conference possible for you the last 2 days. And I'm so enjoying every minute of being here to experience it with all of you. Because without you, I'm pointing to all of you here, without all of you attending this conference, without all of you at home tuning in for the live stream, without our talented speakers coming to share their technical knowledge, and without the community supporting us, we wouldn't be here today. Now, equally important to the people that helped to make this conference possible are the technologies that are represented here, right? Current was founded with Apache Kafka at its core. It's the next generation of Kafka Summit, isn't it? But Kafka is just one technology, and I hope I'm not upsetting you in saying that. It is a very, very important technology, right? And while a lot of the agenda that we're seeing today is informed by trends that we're seeing in the Kafka community and use cases around there, the rest of the agenda is informed elsewhere by trends in the broader data streaming community and industry, what you and your companies and organizations are doing with these data streaming technologies each and every day. And so this year, with those trends in mind, our technical agenda has expanded to cover over 30 technologies in the data streaming space and broader ecosystem. But don't worry, there's still more than enough Kafka to go around. In this morning's keynote, we're definitely going to cover all things new and exciting in the world of Apache Kafka. But I think it would be a missed opportunity if we didn't also check into some of those other trends that we're seeing. And so with that in mind, we're going to dive into another technology that's currently trending in the data streaming space, Apache Flink. And to shed light on Apache Flink and where it's situated alongside Kafka in this broader data streaming picture, I'd like to welcome to the stage 2 leaders in this community, Ismael Juma and Martijn Visser.
Wow. So Ismael and I are super excited to be here today and talk to you about stream processing. Yesterday, we already heard Sean talk about the elements of a stream processor and the elements that are involved in that: stream, connect, process, and govern. And when we're talking about processing, we're talking about the manipulation or transforming of data into a more meaningful form. Examples are things like cleaning your data, filtering it, transforming it into a different format, and of course, applying calculations on top of that. And with stream processing, we're just making that real time and giving you those real-time insights. And Kafka and Flink are the foundation for these type of things, for the streaming and for the processing. They go together like peanut butter and jelly. Now I'm actually curious, Ismael, why do you think that Flink and Kafka are such a great match together?
That's a great question, Martijn. To help answer this, I will use an analogy between data at rest and data in motion. When we started building applications for stored data, all we had were file systems. File systems are a powerful abstraction, but they're pretty low level. So as we built more and more of these applications, it became clear that we were writing the same code over and over again. This led to longer development cycles, but also it was error-prone. There was an opportunity for introducing a new abstraction that integrated storage and processing to make it dramatically easier to build data-centric applications. This is where databases come in, particularly relational databases, but also other paradigms. And this is the standard of how we build data-at-rest applications today. So we've talked about the evolution of the data-at-rest stack. What about data in motion? Well, it's pretty similar. At the lowest level, we have Kafka, the central hub where we write and read streams of data. It's a powerful abstraction as well, but also a little bit low level. You can write sophisticated applications using directly on top of Kafka, using the producer and consumer APIs. But it's a great deal easier if you are to use some higher level abstractions that provide some ready-made solutions for common patterns. When it comes to simple Java applications, Kafka Streams is a great option. It's a library. It can easily be embedded into the application. And it provides many of these core stream processing primitives and makes them readily available. And it's very successful in this space. But it is not quite the database of the streaming layer. For that, I would look towards frameworks that try to do even more. They take control of the life cycle of the application and take care of all the scaling, failover, fault tolerance, and more of that good stuff. Flink is one such framework and one of many. So Martijn, what makes Flink stand out in this space?
Ooh, that is a good question. I'm a bit biased in this, but I think there's three elements involved in here. I think it's about the APIs, the runtime, and the community behind it. So if we're looking at the APIs, Flink offers unified batch and streaming APIs for processing this data. It allows you for different levels of abstractions, so it supports both common as well as specialized use cases. So when you have created your business logic, it's being run on Flink's unified runtime. And that is a streaming runtime, which basically gives you the ability to get really high throughput yet low latency results. And from a community perspective, we see that Kafka and Flink have this similar growth path. They are the same set of companies that have adopted Kafka at first, or also early adopters of Flink. And what we have seen in the Flink community is that it has been super active. There's 370 flips, 150 committers, more than 34,000 commits in general. There's a Chinese mailing list for users as well. And I really think that it's the diversity of the community and its broad audience in there, where we have these great engineers, data analysts, and everything, that helped harden the technology and has resulted in that incredible progress that Flink has made over the years. And it has resulted in Flink becoming the de facto standard for stream processing. Later on, I will tell a bit more on what the plans are of the community with Flink. But perhaps, Ismael, you could tell us the latest on Kafka.
Sounds good. Thank you, Martijn.
Thank you.
So, we all know Kafka is the foundation of the streaming world, and it has been maturing for many years. Does that mean that we're done? Not at all. There are still some very exciting foundational changes happening in the Kafka space. I'll be talking about what we've done recently, what we're working on right now on hardening and rolling out, what's on the horizon, the next set of things the community has been discussing that we're quite excited about, and some future ideas, some more forward-looking things that we think would make a big difference to the ecosystem. So let's start with what we've done recently. By now, I hope all of you have heard about Craft, Kafka's new metadata layer built on a replicated log. This has been a multi-year project that involved a number of contributors from a variety of companies and organizations. And it brings significant benefits. It's easier to manage. You don't have to operate a Zookeeper cluster anymore. It scales much better. The number of partitions supported is an order of magnitude higher. And it's more resilient. A number of edge cases have been addressed. Craft has been in production for some time. In fact, we announced it in this very conference last year. But the big news is that you can now migrate your ZK mode clusters to Craft mode completely online without any downtime. We have also officially deprecated ZK mode and intend to remove it in Apache Kafka 4.0 next year. So please, start your migrations as soon as you can. So, what's next? This is another large re-architecture in the core of Kafka. The separation of compute and storage by supporting multiple tiers of data, also known as KIP 405. By moving the colder data to an object store like S3, Kafka becomes more elastic and easier to operate. Operations like expanding the cluster or replacing a failed disk are much, much faster. And it also provides an opportunity for using faster, cheaper, and also smaller hard disks, or SSDs. This project was started by Satish Duggana and his team at Uber some time ago, But it has been truly a community project since then, with contributions from a number of companies like Confluent, Amazon, Ivan, and Red Hat, and many individual contributors. To tell us more about tiered storage, we have Satish today with us. Please welcome Satish to the stage. To get us started, Satish, please tell us a little bit about your role and how Uber uses Kafka.
Yeah, I'm tech lead at data and streaming infrastructure at Uber. We have one of the largest Apache Kafka deployments in the industry, serving trillions of messages per day and several petabytes of data per day. We have a Kafka platform, which is the critical cornerstone for entire Uber tech stack, powering several critical use cases. Some of those use cases include real-time propagation of events across thousands of services in pub/sub manner. It also enables streaming analytics platform, which is powered by Apache Flink and Apache Pinot. It serves several critical use cases that includes dynamic pricing, ETA, real-time data exploration. It also enables observability platform, which is about logging and debugging across all the Uber's development stack. It also ingests a lot of online transactional change data capture logs, which will be consumed by several thousands of services. We have ingestion pipeline, which is powered by Apache Spark, the subsystem, which pulls all the variety of data and pushes into Uber's data lake.
That's really cool. So moving on to the tiered storage kit, can you tell us a little bit about the high-level architecture?
Yeah, KIP 405, it introduces separation of processing and storage at Kafka broker level. It is a fundamental core change that brings elasticity and scalability to the cluster. While building this solution, we have few principles in place. One is no changes required on the client side. That means there is no need to change the client library or no need to set any configs. You'll still be able to access the data that is in remote storage. Right? The second one is no new replication protocol. So the solution is built on top of the existing battle-tested replication protocol. The third one is giving a very simpler interface for plugging in the remote storages. And at a very high-level overview, this can be divided into 3 parts. So the first part is copying all the eligible segments from local storage to the remote storage. Right? The second one is maintaining the log segment lineage and consistency semantics across the local data and the remote data. The third one is about fetching the data from remote. This is done through a specific purgatory and thread pool.
Sounds good. I think it's really cool that we managed to have such a large architecture shift without updating the clients or having any external protocol changes. Great achievement. And can you tell us a bit about running KIP 405 in production and any interesting lessons or benefits from this?
Yeah. So we have tiered storage in our production clusters. Majority of our production clusters, which are around 80% of the brokers we have tiered storage on them. And some of the large clusters we've been running for last 9 to 12 months. So some of the major benefits here that includes it improves scalability and elasticity of the clusters, and the cost efficiency in our on-prem clusters, we saw 25 to 30%, they've become more cost efficient. In our preliminary analysis of cloud object stores, we saw the cost efficiency can range from 30 to 70% based on different set of use cases. The third point is the rebalancing the clusters. As you all may know, it is very complex process and it takes longer durations. So in one of the use cases, we observed it takes around 18 hours to do a rebalance of that cluster. So when we enabled tier storage, it came down to 6 hours. The fourth one is rebuilding the failed brokers. So in one of the large clusters, it took around 8 to 9 hours. When you enable tier storage, it came down to 3 hours. We worked on a new feature called follower fetch from tiered offset instead of local log start offset, which actually brought it down from 3 hours to 1 hour.
Awesome. I'm sure the Apache Kafka users are really looking forward to these changes as well. When is TS storage going to be production ready? And what's next for TS storage in general?
Sure. Yeah, so we are going to have early access release in 3.6.0. We are almost finalizing the release. We had a couple of release candidates, and we are going to have one more release candidate. In 3.7.0, we want to have tier storage as production ready, adoption ready, so that all the known gaps will be closed. Some of the new features that we're going to introduce in 3.7.0 is better topic deletion lifecycle management. This is already proposed in KIP 405. So this will implement it in 3.7.0. And the second one is remote read and remote write quotas for better reliability across Kafka clusters and also on remote storage. The third one is follower fetch from tiered offset instead of local log start offset, which I talked about earlier, which brings much more availability to the cluster. The final one is we're also experimenting having dedicated remote replicas where you can quickly bring up remote read replicas and serve all the remote traffic only through those replicas.
That's awesome. I'm looking forward to 3.7 and using tiered storage in production. Thank you, Satish.
Thank you.
A round of applause for Satish, please. So let's talk about what's on the horizon. The next set of things we have been discussing with the community, and in some cases working on, that some of us are very excited about. When it comes to an open source project, it's a little bit difficult to talk about the roadmap. After all, innovation comes from everywhere. Anyone can contribute a proposal, an idea, or a feature. But we think that these items give a good sense of what's coming. The Kafka protocol is the core contract that Kafka exposes to the rest of the world. Since Kafka has become the de facto standard for streaming, the Kafka protocol is for Kafka is for streaming, the same way that HTTP is for REST. Given this, it's critical that we continue to evolve the protocol with compatibility in mind so that we set up for success in the next 10 years. You may be wondering, if I'm using a client application, why do I care about the protocol? After all, we have a rich set of clients for a number of languages, and as a user, you're interacting directly with these APIs, not the protocol. The challenge is that the protocol today pushes a bit too much work for the clients. As a result, it takes a significant amount of effort to make the clients really amazing. We have some of them. But we also have some clients that, let's say, are less amazing. And we want to make them equally good. How do we do that? In my opinion, the solution there is to simplify the protocol. And this is what KIP 848 does. It moves a bunch of complex logic that today exists in the client, it moves it to the server, things like metadata tracking, subscription management, and so on. In addition, KIP 848 also removes a global synchronization barrier that has been a real pain point in previous iterations. So it makes the consumer group protocol more scalable and more reliable. There is this core general problem when people are trying to integrate the apps with event streaming. You want to both maintain some state in a database and keep it in a consistent fashion in your event system. Let's say a user joins your organization and you store that data in the database and you want to keep Kafka in sync. What do? Can you simply write to both of them in parallel and expect consistent and atomic behavior? Not today, but this is what KIP 939 attempts to solve. Anna McDonald and Gordon Tai will talk about this exciting KIP in more detail a little bit later in the keynote. Development experience is critical for the success of many types of projects, but even more so for an open source project like Apache Kafka. One of the KIPs in this area that I'm really excited about is this KIP that allows the usage of GraalVM's native image to reduce startup time, memory usage, and the size of the Docker images. Initial results here are actually extremely exciting. The startup time has reduced by almost 10x, and the memory usage reduced by 4x. I'm personally really looking forward to starting Kafka in 100 milliseconds. And last but not least, Queues for Kafka is a pretty elegant proposal on how to enrich the Kafka protocol and Kafka APIs to make it easier to build to satisfy some use cases. And I'm not going to lie, this is somewhat of a controversial topic. But we have here today with us the KIP author, Andrew Schofield, to tell us more about Queues for Kafka and to even give us a demo. Please, a round of applause for Andrew Schofield.
OK, thank you, Ismael. So I'm not sure this is controversial. I think it's really just evolution. So let me tell you about the difference between a message queue and event streaming to start with. So they're really kind of the two different ends of the same spectrum, I suppose. Message queuing originally started as a kind of point-to-point integration between two communicating applications. And event streaming has really turned into more of a kind of a foundation for a data streaming platform. Okay? But there's plenty of middle ground, and we're really going to be talking about that. So the question is, given that event streaming is this kind of more general and more powerful paradigm, why didn't it just simply take over from message queuing? And the answer is, a message queue is a really useful abstraction for certain kinds of use cases. And I'll give you an example. So imagine you were trying to do order fulfillment. It's a really natural kind of way of thinking about it, that you put all of the orders onto a queue, and then you have a pool of consumers who process the orders one at a time, and then take them off the queue, and then you've got a very good model for handling the orders as they build up, and also for processing them. And that's relatively difficult to do with an event streaming system with its standard API. So message queuing systems are characterized by per message state. So when a message gets sent onto a queue and received from a queue and acknowledged as being delivered, then it goes through this sequence of states, and the message queuing system remembers all that information as part of the way its API works. Consumer position is handled very differently in an event streaming system. So what typically happens is the consumer consumes a bunch of messages and then periodically updates its consumer offset. And that's really not so convenient if you're writing an order processing application. You want to share more freely than that. So using a consumer group, specifically in Kafka, is not very good for that kind of model. So what we'd really like to do is to see if we can kind of merge these two concepts to some extent and provide something more general. And in the order fulfillment example, aren't they just a stream of events, the orders coming in? Well, I think they are an event stream, really, but it's a queue as well. So you should be able to view it in both ways, and that's what this KIP does. And I'll give you an example of an improvement you get if you put your queues on top of Apache Kafka. So message queuing systems use a model called destructive consumption. So what that means is you take a message off a queue, it's gone forever. There's no memory of it at all, it's just disappeared. But Kafka has much richer ways of handling storage. You can do it by time or by capacity, and then with innovations like KIP 405, you can potentially have infinite storage. So if you put your queue on Kafka, you could wind it back in time to a different point for recovery, for example. So let's have a look at what the KIP actually offers. So it's a much anticipated feature to be added to Kafka. It makes it much easier for application developers to write kind of queuing style of applications. Excuse me. It introduces a new concept called a share group, and a share group gives you easy and flexible sharing on top of Kafka topics. There's no partition assignment, so you can exceed the number of consumers or the number of partitions with your consumers. And it also counts the delivery attempts. And the advantage of that is, if you have a message which is repeatedly failing to be processed, you can have it removed automatically from the queue so it doesn't block things up. So this is how a consumer group looks today. I've got 3 partitions in my topic here. Only 3 consumers can be active at a single time, consuming from the data. So that limits your parallel processing. A share group looks very different. It's as if the data from the partitions has been merged into a single virtual queue, and then you can have as many consumers as you like on that queue. Now inside, it doesn't work like that at all, but that's the model. The application style is very, very similar to today's with just using a regular Kafka consumer. You replace the Kafka consumer with a Kafka share consumer, and there's a new verb called consumer acknowledge, and that basically says whether the message was processed or not. And so that's what a share group consumer looks like. Very, very similar to people who are used to writing normal Kafka applications. So in the spirit of show and don't tell, I'm now going to run a live demo. So back to order fulfillment. The orders we're going to be fulfilling are for hot dogs. So what we've got here is we've got 3 chefs who are going to be making the hot dogs, okay? And they are joining a share group, and they take an order at a time in order to make a hot dog. So what I will do is I'll start up one of the chefs. And then down behind me, there's a load generator that generates a hot dog order every few seconds, so you can see the progress of it. So now we can see that the top one is making hot dogs. And I'm going to start some more chefs. And what you expect to see is the message is being distributed across the chefs. And there we are. We've got one for the middle chef. Now, the interesting one is the bad chef. The bad chef, unfortunately, has no onions, is incapable of making a hot dog. So what he does is he puts it back on the queue, and then it's been reprocessed there. You can see attempt number 2. So the attempts have been counted. You've got reprocessing, and all this is being handled naturally using a Kafka API. And now I'll show you what it really looks like. So it's a single partition topic, okay? Each hot dog order is one message, and when you do reprocessing, it doesn't put it back on the topic. It's just being re-delivered by the share group. And this is actually, a modification I've made to Kafka running live in front of you. Can we switch back to the slides, please? So what next for KIP 932? Well, there's some more decisions to be made. It's obviously a big piece of work, and the prototype is incomplete at the moment. So I'm going to enhance the prototype to validate some design choices, give it things like persistence and worry about performance and that kind of stuff. And then we'll be in a position to finish the KIP off, prepare it for vote in the community, and then start delivery of the code. And then we aim to get KIP 932 into Apache Kafka in 2024. So if anyone would like to talk to me about it, then come and find me on the conference floor. I'll be happy to chat. And now I'll hand back to Ismael. Thank you very much.
As we look towards the future, and we think about what things would make a material difference to the platform and ecosystem, 2 things come to mind. The first is a mechanism to organize topics. As we talk to customers that are using Kafka at scale, it's very common that they have some complex mechanism to name topics. It may contain multiple groups, things like maybe a team, an application, and so on. When you think of data at rest, there have been a number of ways to help with the structure of tables and such things. Directories, tags, labels are a few examples. I think something like this would be helpful for Kafka, an abstraction that helps us structure data, helps us understand what's private versus public, and allows us to understand, if it belongs to a team or an application. And equally important, it allows us to evolve the structure with something like, say, symlinks or the ability to rename topics. We haven't yet a concrete proposal on how to do this, but it is something we'd like to work with the community on. And last but not least, partitioning is an area of Kafka that is still a bit more complex than we would like. Users have to understand some internal details of Kafka to make the right choice here. Choose too few partitions, and the system may not scale appropriately. Choose too many, and it is unnecessarily inefficient. So how do we fix this? There are a few options. We could dynamically split and merge partitions. We could also auto-scale them. Or we could remove partitions altogether from the system and focus on key-based ordering instead. One or more of these options would dramatically simplify the foundation of the system. And when it comes to this core layer, this is really what's important, making the system as simple as possible while keeping its power so that we can build a successful ecosystem around it. We've gone through a rich and exciting set of things. As we look through these items, the defining feature of the Apache Kafka project, continuous innovation, is in full display. As they say, many hands make light work. So when it comes to an open source project like this, there's a huge number of contributors from all sorts of companies and organizations that build these features, that make sure that they are well documented, that they're well tested, that they work in every scenario in all possible edge cases, that they scale, and many more of these things. Something that we can truly rely on. A huge thank you to all the people who make this possible. And now, putting theory to practice, we have someone, Tobias Nothaft, product owner from the streaming platform at BMW. He's going to come and tell us how BMW uses Kafka. Please welcome Tobias to the stage. Welcome, Tobias. Can you tell us a little bit about how you use Kafka at BMW?
Sure. So we're a team of 20 people providing platform and infrastructure services for our internal users. This platform comprises of around 25 Kafka clusters in Europe and in the US, used by application teams to transform more than 3 billion events every day. We're also planning some more locations, such as Mexico and South Africa, to get close to our factories. And we're also partnering with our Chinese colleagues so that they can offer a similar kind of service in China as well. To make our users' lives a little bit easier, we're not only providing Kafka, essentially, but also other services, such as topic replication, schema management, or connectors. So for example, we're currently hosting more than 1,000 connectors, regular connectors, and another 100 instances of our own custom-built SAP connector. A key component of our platform is our self-service portal, which is used to bring the services to our users so that it is easier for them to use them, taking away some of the time-consuming manual activities such as infrastructure provisioning, but also other things like generating interface contracts automatically and transferring the information into our config management database. The platform is used by around 500 application and product teams with various use cases. So we have a wide variety of those, from very simple ones where they just go ahead, have a connector to provide their data assets as an event stream, or some of them even just using it more like a messaging solution. But we also have large case streams, topologies, that they use to continuously generate new information all the time.
Awesome. I'm always very interested to hear and learn about how businesses use Kafka. So what would you say are the areas of the business impacted by your work? How does it all translate to the customer getting into their car?
So our idea is really to provide that platform just to anyone within the BMW Group. Many of the services have initially been established in the car manufacturing as they decided early on for a strategic move towards Kafka. So there are lots of critical use cases relying on us, such as the transfer of just-in-time and just-in-sequence information to our production lines. Or there's also a fleet of autonomous transport systems that is moving parts within the factories on their own that would not be able to do their job without Kafka. So while we're not having that one mega use case with trillions of messages every day that probably some members here in the audience do, our manufacturing is really, really dependent on the reliability of our services. Since this was quite successful, the other business areas saw the huge benefits of the platform and then followed quickly. So for example, R&D is now providing lots of valuable data streams about parts master data or the bill of material. That includes also a bigger project integrating our mainframe to Kafka. Sales and after sales, on the other hand, they're using a lot of information for keeping up to date with customer orders and offering the right products at the right time. So to answer your question, basically without Kafka, none of our customers would ever get a car.
Wow, there's a lot resting on Kafka's shoulders at BMW. I'm sure your team didn't hit the ground running from the beginning, though. You probably had to go through many stages to get to where you are today. So where did you start, and what was your journey?
Yeah, that would be amazing, having such an advanced service offering right from the beginning, right? But no, you're absolutely right. We started very small, actually, in December 2017, where we've just provided a building block for our OpenShift-based private cloud environment. So I've bundled together a few services as templates and just passed that on to application teams that were interested in just running the Kafka clusters themselves. And this was quite successful, which resulted in more and more use cases coming up even in the critical environment. And that was also the reason why some of the teams asked me whether we could not offer that as a central services for them, where we operate the Kafka clusters for them. since they were lacking the expertise to do so, guaranteeing the availability. So I sat together with a colleague, and we enabled a provider to do the 24/7 operations, agreed on all the procedures needed surrounding that, and then started that early in 2019, offering that service. This was also quite successful and stable from a Kafka perspective, but we were facing major issues in the underlying private cloud infrastructure, which really became a major roadblock in 2020. So we had to take a decision how we move forward from there. And yeah, we just followed the natural evolution that we have gone through so far already and moved on to the public cloud, where we've had our first productive go live in July 2021 then. Since then, service has been expanded with more and more services, more users all the time. But this massive growth, which was a bit unexpected that it's so massive, has come with a number of challenges as well. So as you know, using Kafka can be quite complex. And unfortunately, there's not an infinite amount of expertise available. And we also, as a platform team, have a limited capacity, which means we cannot just simply consult each and every of the teams in depth to help them with that issue. So this is really leading towards lots of additional effort on our side that we have to cope with, helping them out of the situation. On the other hand, our community is really also one of our biggest strengths, since we've come up with some cooperative work where we have released features in a very short amount of time that we would not have been able to do so on our own. The public route migration is one very good example for that, where we've built a completely new solution together with a team from the production IT within just a few months.
Nice. It's nice to hear how Kafka grew along with the company over the years. The natural evolution is a testament to the open source community driving change within the technology as well.
Yeah, absolutely right. And we can actually see this in some of the amazing work that the community has brought into Kafka. So as a company that exists for a very, very long time, we're often faced with a requirement to modernize business applications that exist for decades, often based on highly transactional patterns. So improvements such as KIP 6108 with the exactly once support for source connectors, or also the ones that you've just mentioned with queuing for Kafka and two-phase commit, can be extremely good enablers to get those use cases onboarded to Kafka as a first introduction. But also we as a platform team are really benefiting a lot from the different features that have been introduced to provide that operations at scale. I don't think that I really have to mention craft. I think anyone involved in operating Kafka has that on the agenda anyway. But there are also other things like KIP 875 with the possibility to reset offsets for connectors, which is really, really one of the features we were looking for. And it's also one of the things why we will really go ahead and update our clusters even quicker than we usually do, just to get this out into our environments.
Fast upgrades, music to my ears. It sounds like your team is doing a lot to encourage adoption and allow Kafka to grow within the company. In the context of the natural evolution of these technologies at BMW, what's on the horizon for streaming for you? Anything exciting?
Yeah, well, there are always tons of ideas, right? And sometimes it feels like never-ending effort. But there is one use case that currently stands out to me in terms of technology stack and the possibilities for the future. So this is another one from manufacturing, where we have a group of machines that are working together to produce parts, and they can be configured to process any kind of different part. The ones really needed depend on the car types moving through the production lines. And it's quite amazing how many different variants of a car you can produce in a single production line. However, the problem is a bit that lots of the older manufacturing execution systems are built for linear production. They're not capable of doing that parallel scheduling of production. So that's where the new solution comes into play, coming up with an optimized target instruction for each of the parts and sending that back to the manufacturing execution system. What makes this really interesting to me, though, is the usage of Apache Flink, which has been chosen after looking into various frameworks. And Flink provides really the features the team needed for this use case, with high performance, but also self-optimization of the jobs, and the possibility to integrate systems that are not only Kafka, but also others, to also include, for example, machine parameterization. So this use case is currently rolled out in our very first plant for electric vehicles. But at the same time, this is a blueprint for our global factories. So this is really a major boost for the production of such parallel things. And it will be very important for the production of our new cluster architecture-based vehicles, which have recently been showcased with our BMW Vision Neue Klasse. So me as a platform owner, I'm often faced with a request from users for help with larger streams topologies and having issues operating them. And I really see a huge possibility here with Flink to provide another option that helps them really focus on what they want to do and less on how to do it while getting us closer to the business.
Sounds great. I'm particularly really looking forward to the cars that come out. They are inspired by the Neue Klasse. And thanks for sharing your perspective on how BMW uses Kafka. And with that, let's welcome Martijn back to the stage to talk about Flink.
Thanks for having me.
Customers and companies are more digital than ever, and more data is being produced every day. Customers' expectations have changed, and real-time services have become the standard. But yet, preventing a fraudulent attempt of renting a car with a stolen credit card is still actually quite hard to achieve. And expanding such a use case to also send a notification when the fraud attempt has been stopped, or even sending a new card, just takes more time and resources than are desired. Customer expectations are even bigger with all the buzz around AI, large language models, and machine learning. And integrating data with AI providers or using that data as your feature store or as training data is critical to get value out of all these technologies and out of artificial intelligence. Now, all of these real-time services rely on stream processing. And of course, you can build them yourself. Most of us start with the average Kafka client to produce and stream your streams. But as use cases mature, requirements also change. And there's a need to abstract patterns via APIs to improve things like time to market. And things like scalability, lifecycle management, and fault tolerance are becoming more important to support these changed customer expectations. And that's why we have seen that Flink has emerged as a de facto standard for stream processing. Now, Kafka and Flink are used by the most technically sophisticated companies in the world. Like I said earlier, these are the same set of early adopters for Kafka, and that we are also seeing with Flink. And we know that 80% of the Flink users actually use Kafka. Flink is a framework that makes it easy to process streaming data in real time. It's built for streaming, and it treats batch as a special case of streaming in its unified runtime. There's a wide variety of unified batch and streaming APIs that range from SQL to Java and Python. And you have the ability to seamlessly switch back and forth between the different options that you have in here. Developers choose Flink because of its performance and a rich feature set. Scalability and performance, fault tolerance, language and flexibility, and unified processing. Let me dive into each of them. First off, Flink is renowned for its scalability. What basically happens is when you are submitting a Flink job, it's being parallelized into thousands or hundred thousands of tasks. And there are known use cases where Flink has scaled up to process 6.9 billion records per second. Next off, Flink contains a fault tolerance mechanism of checkpoints. It periodically takes incremental and asynchronous snapshots of all the state, and it writes them into a more durable storage like S3. Next to that, Flink users can also trigger save point for manual backups, or for manual operations. In case there's a failure, like the crash of a task manager that's executing those parallelized jobs, the job manager, which controls the entire lifecycle, will detect that failure and will make sure that the job gets restarted from its snapshot. That enables Flink to recover from failures in a timely and in an efficient manner. Flink has these layered APIs at different levels of abstractions. On the most declarative level, there's Flink SQL, which gives you a pure ANSI SQL ability to write your statements and get easy started. One level lower, there's the table API, which is the programmatic equivalent of SQL, so you can use it to write your Java or your Python applications. And on the lowest level, there's the data stream API, which gives you a low-level imperative API for direct access to building blocks like state and timers. Now, in a Flink job, data flows through a data processing pipeline, which we call a job graph or a topology. What we see here on screen is an example of a SQL statement where we're writing into a results destination topic and we're reading from an event. Those could be Kafka or anything else. What is happening is that when you're using the SQL solution or the table API, the job graph is being created for you. It does so by validating, optimizing and transforming that into a job graph. If you're using Flink's data stream API, you actually have to define the entire job graph yourself. And last but not least, Flink has this unified stream and batch processing. Flink is a generic purpose tool. You can use it for both common as well as specialized use cases, independent of the type of data that you're using. If you have a need for low latency requirements, you would use streaming execution, which means that results will be generated while your data is being processed. With a batch execution, you get one final result after completion. So Flink is absolutely a great tool, but it does come with its challenges. Operating Flink on your own is actually quite difficult. There's a layer of deployment complexity involved. Setting up Flink requires you to have knowledge of Flink in things like resource management and resource allocation. If we're looking at management and monitoring, Flink has a wide variety of metrics available, but picking the right metric to get started can be overwhelming, especially if you're just starting with stream processing. And because Flink is a framework, it lacks pre-built integrations with systems for observability, metadata management, data governance, and security tooling. And of course, operating Flink on your own does mean that you have to incur costs, both from an infrastructure perspective as well as from an engineers or resourcing perspective. That is why we at Confluent have been working on the first truly cloud-native Flink service, where you only have to focus on your business logic and not in infrastructure. It's the first true serverless, zero knobs, usage-based SaaS solution out there. And yesterday, you've seen a variety of Flink features already in action in the day one keynote. And today, I want to explain or highlight 3 Flink features that I think you should actually know when you're starting with this. Windows, because windows are at the heart of stream processing, where you're grouping streams based on time or key-based criteria. Temporal joins for efficiently joining data across multiple streams. If you're thinking about doing a regular join on a streaming source, you should probably consider a temporal join. And pattern recognition, where you're doing complex event processing for pattern matching in streams. First, let's look at windowing. Like I said, they are at the heart of stream processing. They are snapshots of data at either regular intervals or after a certain number of events. Take an example where you're streaming in factory data and you want to use that to power a dashboard to determine the number of errors that have been reported per minute. If you would have a need like that, you would probably use something like a tumbling window. Flink has a wide variety of windows out of the box available. You can use a tumbling window, but also a sliding or a hopping window, a session window, or even global windows. And of course, you can combine all these operations with other features like deduplication, top ends, or joins. In yesterday's demo, we had an example of a regular join in there, but Flink also has a concept of temporal joins. What you're doing in here is that you're joining 2 streams based on a time attribute. In other words, you're joining based on the data when the data was created or updated. What we have on screen is an example where there's a mobile application user and a separate stream which contains customer lifetime value from, let's say, a stream that contains a feature store. It says feature store. And what you're doing with that is that you're joining at the moment when that data, you're joining them at the moment when you are having to execute that time-based join. Now, one of the biggest advantages that you have for temporal joins is that with a regular join, you have to take into account that that result might be changed into the future because there's new data coming in. But with a temporal join, you're only interested in the value of the data at the moment of the join. The ability to recognize patterns and react to events in a timely manner is something that you do with complex event processing. You could have a series of small transactions followed by a large one, which might be an indication of fraud. Or you could have a situation where you have a double bottom example, where you have a low price followed by a small increase in price and then bumping it again. What you could do is you can define in either SQL or Java or Python, you can define a pattern matching pattern for that. You use that with regular expressions, you can measure calculates, you can define measures that calculate aggregations for that pattern. And you can also define conditions for those patterns, like an ordering or the actual value that's happening in that data. Now, hopefully this has given you some insight on why Flink is such a powerful tool and how you could actually use it. Let's have a brief sneak peek at what we think that Flink will evolve to into the future. Technology is advancing and Flink does too. The community is currently planning and working on Flink 2.0, which would be the first major version of Flink since 2016. There are 3 elements in here that I want to highlight from that discussion. First off, the mixed execution mode. Like I said, Flink has this stream and batch unified runtime. But one of the powerful things that the community is planning to do is actually to use those modes in one single job. For example, if you're starting a backfill from your Parquet files, reading from Parquet files on S3, and then seamlessly switch in the same job to a more efficient streaming when you're actually caught up on that backfill and switch it towards Kafka. Currently, it would require a stop and switch. In the future, we would just automatically choose the right execution mode. Second off, there are evolutions planned on the SQL engine and to support things like streaming warehouses. It requires support for updating statements, stored procedures, delete statements, and so much more. It's all foundational for supporting and improving on lakehouse technologies like Apache Iceberg, Paymon, Hudi, and many more. And with a streaming warehouse, we are combining the benefits of a traditional warehouse, but they're always up to date and they contain the last insights on that. The last item I want to highlight is the removal of deprecation APIs. There's a variety of APIs in Flink that have been originated from the batch world, which will be fully deprecated so that there's only that unified API layer in there. Overhauling the configuration layer, looking at the source and sink interfaces. But more importantly, we're looking at new abstractions for direct access to those building blocks like state and timers. And we want to make sure that there are no internals in there. So all in all, the community is super excited to work on this. And I think it's going to be super interesting where Flink further evolves into the future. One of the benefits of stream processing and how widely it's used out there is also that it's great to listen and hear how others are using that and be inspired how they see stream processing evolve. And to hear more about that, I would like to welcome McDonald and Hitesh Seth on stage.
What up, everybody? How's it going? I'm McDonald, technical voice of the customer at Confluent, and I'd like to welcome Hitesh from JPMC. Why don't you tell us a little bit about yourself.
Thanks, Anna. I'm glad to be here. My name is Hitesh Seth. I run the architecture and engineering for Chase data platforms. These platforms run the core businesses in Chase, including deposits, credit cards, auto loans, home loans, and Chase Wealth Management. I'm also responsible for the engineering of core platforms such as data processing and stream processing. I happen to also run the architecture and technology strategy for AI/ML at Chase.
That is awesome. So, Hitesh, you have been in technology for a long, long time. And what makes you excited about Flink?
Yeah, so for a long time, right, we've been building applications that are message-driven. Right? So there was an era of message-driven applications that started with message queuing and other capabilities. We then sort of evolved to building pub-sub sort of applications in the past. And these applications have really given us a lot of flexibility in terms of decoupling the nature of multiple systems. With Kafka, things turned up another notch, right? We started seeing events that are not just business events, technical events, observability, all sorts of events started flowing in the enterprise. And with Kafka, you got the producer and the consumer model, right? But what ended up happening is that we as developers ended up building a lot of infrastructure code because we had to understand which brokers do we connect, what areas do we do, what do we do in case of failures, what do we do in terms of switching brokers or things of that sort, right? So there was a lot of infrastructure code that we had to write, and a lot of companies ended up writing frameworks to deal with that. Did we process every single message and those certain things for it? So Flink really kind of takes this to another level because you get the abstractions, like the SQL API, the data stream API, and others, which focus the developer on writing business logic, right? So you can really solve the problem that you need to solve versus focusing on the, how the infrastructure is laid out. And the abstraction became a lot more possible. And this is very important in our kind of nature of world that we live in the cloud world, where containers can literally die or spawn anytime. So that level of resiliency and that level of decoupling is really important. And I think Flink has given us a way to manage that in a lot more approachable way.
Yeah, and speaking of problems, or as we like to say, use cases, when you look at the stream processing cornucopia, it's fall, I'm saying that, what are the top 3 use cases that you can see Flink driving in the industry?
Yeah, there is there's a stream of, or a structure of use cases that we should talk about. One is, we just talked about all these streams moving into the organization. One is simple, ingestion, right? Where you take the data that is flowing into data streams and business streams and essentially capture that into your lakes and the warehouses. So that's rare. That's now available for analytics, right? You want to understand, how things are moving in. So for example, how many accounts are you opening in? Did the promotion that you just launched or did the ad that you just launched created the areas? So that's simple ingestion. That itself is a lot of value because you are now be able to take the data that flows in and now you are able to understand it. Next, move to another scenario where we're talking about enrichment, right? So now you have a basic message that is emitted by a system, and let's say that system is about an accounting platform for creating new accounts or managing account changes. So in that scenario, that system knows the language of accounts, but you want the language of customer to be the core of your enterprise. You want to be customer-centric and areas. So you want to connect that and enrich it with customer information. So you want to tag that message with customer-related information so that it can be used with other areas. So that's enrichment. Now you talk about trying to go for next best action or events processing, right? So you just created a new account. What do you want to do next, right? Do you want the customer to, how do you want the customer to engage with that particular account? So you want to start early engagement. And maybe you want to do differentiated behavior depending on the level of the account or the nature of the account. So that's basic stream processing. Things then become very interesting when you try to combine multiple streams. So you've got business events like creation of new accounts or a change in an account, and you have interaction events, which is things like what did a customer do on a call center, or what did the customer do on their mobile site or on a website. And that's really interesting because now you can say, oh, such and such customer started an application in one channel, but never completed it. So when he or she goes to the next channel, which is maybe a call center, you may want to whisper into the call center and say, this customer may want to look at that as an example. So those are the areas. One particular area that I find to be fascinating in the nature of stream processing, and particularly with Flink, is what I consider future-proofing. So what that means is we in our enterprises still have a large range of batch applications. right? And these have traditionally grown from the areas, and there are for different reasons and shapes and sizes. You could take those applications and really process those batches in streams, right? So you can always do batch processing using stream, and then lay the foundation for how those applications can be evolved or transformed in the future. Yeah. So that is a very interesting way of doing it. And with abstractions like the data stream API, which sort of combines stream processing and batch processing, that makes it a lot more simpler.
Yeah, and just overall, you talked about a lot of use cases. What is the end outcome? What outcome are you looking for?
I mean, end of the day, you want to really build experiences that delight the customer, right? And you want to make the customer feel that whether you're going from one channel to another or one product to another, they are, you look at the customer as a whole, and you want to make it very continuity, right? You want to have a continuum of those experiences. So those are the values that you drive. But to do that, you really want to focus on the changes in the business logic. Like, how do you detect these business events? How do you connect them with these technical events? How do you interaction events on different channels, and so on and so forth? So that's really where the confluence of things sort of happen, right? And to do that, you need to focus on business logic. You need to focus on things that are valuable to a customer, and that's really where you can build experiences that matter.
Yeah, absolutely. So I don't think you're officially allowed to call anything a keynote unless you mention Gen AI. So you are also responsible for AI at Chase. Can you share your thoughts on where do you see the impact in financial services?
So been fortunate to work in language models for a while. So in my previous lives, I've sort of applied language models for understanding what's in a document. End of the day, there's still areas where we use documents a lot, or different types of content. We have applied it on document categorization, information extraction, as well as translation, right? You can do real-time translations of documents and other things. So those are the areas that we have already, or at least I have already been part of. With LLMs, things become more interesting because now you can apply these in a much more scalable fashion, right? You don't have to, when we had to build these applications in the past, we had to spend a lot of time training and those areas. Now you can actually benefit from these large models and apply them with frameworks like RAG to really enhance the experiences. So where I see sort of Gen AI and LLMs kind of facing into the future is really taking experiences to another level, right? You think about that all you are doing is you're a customer of a set of products with a company, and you want to be able to conversate with the system, if you may, like the broader enterprise, and you want to say, okay, what should I do next? I want to book a vacation. What are the areas that I should try? Or I want to make a wire transfer. How can I speed up the experience? How can it make it much more natural? And that's really where I think with Gen AI and with LLMs, we'll see the eventual. Obviously, personalization is another key element, right? You want to personalize these experiences that are relevant for the customer. So if I have traveled a lot, and I use a particular airline, so those experiences needs to be now connected. And that's really where this whole connected commerce, connected kind of experiences make sense.
That's fabulous. Well, Hitesh, I want to thank you so much for talking to us today.
Thank you.
And we're going to keep going.
Thank you. It was a pleasure. Thank you.
So again, I want to thank Hitesh for coming out and talking to us about data streaming and the Flink use cases of the future. If we think back to those use cases that were discussed, there's one sort of common element in all of them. They all involve integrating with external systems and Kafka. So what we're going to do is we're going to talk about where we are today in terms of integration with external systems in Kafka. We've got some great patterns. We've enabled use cases across verticals. And then we're going to talk about a KIP that I'm super stoked about. And Ismael alluded to this earlier. It's 939. So I need to keep Kafka in my database in sync. This architectural pattern is everywhere. You see it in insurance. You see it in finance. You see it in retail for inventory management, just a really common requirement. And as such, we've got some pretty successful patterns that we've talked about. One of them is not, spoiler alert, it's the one with the skull. So first one, I use CDC, change data capture. We love change data capture. It's amazing. I've been in love with it for years and years and years. But what it involves is you basically write to your database first, then you pump it out into Kafka. What that kind of necessitates is for you to take data that's in a table format and usually translate it to events. There's some nuance there. Maybe they're going over asynchronously in multiple tables. You need to use completion criteria. But it's been used to kind of power use cases across the board. Then we've got the kind of opposite one, where we're going to write to Kafka first, then we're going to sync it to the database. This usually involves events moving to a table. And sometimes we need to use a staging table over in our database. Things need to be idempotent to handle duplicates. But it's also been used to have that synergy between Kafka and external systems. The third one is dual writes. They're horrible. If you don't think they are, please come find me after. They lead to divergence always. Everyone's always like, but, there's no but. None. There is not a single but. So please, come talk to me after, like that sign, change my mind. I don't think so. So if these things are so awesome, right, and we've used them so successfully, why do we need a future? And I'll tell you why. Imagine this. Imagine that you've just gotten on a flight, and you have paid the upgrade, and you go look at your status, and you're about to hit the next level status. And you look, and you refresh, and you refresh, and you refresh, and you're like, where are my points? They're not here. So you call, and who likes making a phone call? No one. No one likes that. It's annoying. And the person says, oh, yeah, you know, I put it in there, I've changed it. You'll be able to see it in a couple hours. And you're like, liar. I'm going to have to call back, right? And even more significant use cases are when we look at something like prescription status. I need to know if my prescription is going to be filled. Maybe I'm going to run out. Or how about I log into my healthcare portal and I see someone else's information? Yikes. Log back out and log in 24 hours, it doesn't cut it. So that's really why we need a solution that allows more immediate consistency between Kafka and external systems. And that's what this does. It's two-phase commit. Note that 2 is for the phases, not for the number of systems you can string together. You can string together any number of systems. So a quick refresher on two-phase commit. Guess how many phases there are? 2. There's prepare and then commit. In the prepare phase, everybody has to agree. They say, yes, I'm in, yes, I'm in. And then in the commit phase, we commit. Once everybody says yes, there's no going back. So why can't Kafka be a participant yet? Well, there's 2 things. 1, every time you spin up a producer, it automatically aborts any ongoing transactions. You can't do that if you already said yes. 2, we have a transaction max timeout. That max timeout will also abort transactions. So KIP 939 finds solutions and relaxes these. And we're going to step through it really quick in this example flow. Now, the important thing to note here is that the application, in this case, is a transaction coordinator, not Kafka anymore. And there's a couple steps. Step 1, we commit or abort the previous transaction in Kafka if necessary. That's not possible now. It will be possible. That's what makes it so we can continue previous commits. Everything's good. We open up a new transaction in Kafka in the database simultaneously, produce the data to Kafka, commit the data, or not commit, but produce the data to the database. 2 phase, we prepare the Kafka transaction. That's a table that's going to be stored in the database that will have the state of the prepared transaction. 4, we persist, which means, bam, we commit it to the database. Once that's all good, then we can commit our Kafka transaction. We do that, and then if it dies in the middle, we come back up, and that step 1 is what's saving us, because we've already said yes. So this, I hope, makes everyone think about what the possibilities are, because now we can have more immediate consistency in Kafka. I'm stoked about it. I hope other projects are stoked about it. And in fact, we have one project, Apache Flink, that is also so excited that they already have a sister flip. And out to come talk about this is the incredibly wonderful, stupendous Gordon. Gordon, come on out.
So, to follow up Anna's great introduction to Kafka two-phase commit transactions with KIP 939, now I'd like to highlight Apache Flink as the first example system that is going to take advantage of this. The Flink community has been following this KIP ever since its early inception on Confluent. And saying this with my Flink PMC hat on, we're super duper excited about it. So excited, in fact, that there's already a joint sister flip, Flip 319, to integrate Flink with Kafka two-phase commit transactions as soon as it's available, with an aim to further harden exactly one semantics across the two systems. Now, before we dive into what exactly Flip 319 solves for us, let's first think about the question of what does atomic DORIs and transactions have to do with exactly one semantics in stream processing? So let's recall this example sequence flow of a typical application doing atomic DORI to Kafka and the database. And to make this even more interesting, let's consider that this scenario is happening within a stream processing application. Say that this application is reading a few Kafka records, processing it, and we're writing out the results to Kafka and the other transactional database. Now, if this application runs without any failure for all eternity, then obviously the exactly one's problem is much less interesting to talk about. But we all know realistically, software can fail and will fail. And in the event of that happening, we want to make sure that when the application recovers, the state of the world is still consistent. Now, thankfully, with KIP 939, we can do exactly that following a well-known recipe of committing your consumer group offsets alongside with the Kafka transactions. And I say that this is a well-known recipe because a lot of stream processing solutions do this. For example, Kafka streams. And guess what? Apache Flink as well. And this really is the beauty of KIP 939. It works the same all the way from single typical standalone process applications all the way to powerful, complex distributed processing engines like Apache Flink. The only notable difference here, which at this point is mostly just implementation detail, instead of committing the offsets to Kafka and the 2PC decision to your database, Flink actually persists them as part of its periodic checkpoints. And in a nutshell, these periodic checkpoints really provide a consistent view across two main things. First of all is internal compute state, things like Flink window aggregations, and very importantly, the source progress. And second of all is external state, which consists of, across all of the data sinks, the transactions which correspond to the source progress that we're committing. Now, you might have noticed by now already, but the very act of generating these checkpoints, this is essentially a distributed transaction across source progress, Flink internal state, and all the data sinks. We can't really go into the exact details of Flink checkpointing here based on how much time we have, but the main key takeaway here is that Flink is acting as the transaction coordinator here, and it is performing the exact same steps of a sequence flow that we have seen already so far for an atomic DORI. And the only really missing piece here is that Kafka needs to be an eligible participant for 2PC, and that's exactly what KIP 939 gives us. So to bring everything together, we have Flip 319, which is essentially providing a new Kafka sync connector which integrates with Kafka two-phase commit transactions. In previous versions of this connector, we've been relying on various workarounds, such as Java reflections, to work around the Kafka Java client to bypass certain aspects of the Kafka transaction protocol due to its violation of 2PC. Thankfully, with Flip 319, all of that is no more. With a new Kafka sync, Flink users will be able to do exactly one semantic writes to Kafka very solidly. And for Flink maintainers and developers, well, we'll be relying on public APIs provided by KIP 939, so all of that Java reflection is no more, which makes the connector very easily to be able to update it to the latest Kafka client version so that we can always benefit from the latest and greatest enhancements from Apache Kafka. Now, obviously, there's so much more to go into this KIP and Flip. If you'd like to learn more about these two specific improvement proposals, I highly recommend to attend these two sessions happening later today. First of all, there's Justin Ocean, who knows everything about Kafka transactions in and out. Definitely don't miss this talk. And second of all, there's a talk with Alexander Sorokomov and myself. We'll go into the details of KIP 939 and the specifics of this Flink and Kafka integration. Now, with that, all of that said, we've covered so much interesting things today. So I'd like to welcome back on stage Danica to help us wrap things up.
Thank you, Gordon. I'm back again. Did you miss me? I know you did. I know you did. We covered a lot of ground over the last, 70 minutes or so? On the Kafka side of things, we heard about near-term and future innovations that you could expect, right? We had tiered storage, queuing, more simplified clients, partition-free Kafka, and so much more. And really, that's just the tip of the iceberg with this project, right? There's so many improvements being worked on all the time, and it's exciting technology to be a part of. On the Flink side of things, we heard about what Flink actually brings to stream processing, especially with its 4 different APIs for you to choose from. We heard a bit about its runtime, how it scales, and Martijn also introduced the 3 features that he thinks you should know: windowing, temporal joins, and pattern matching. So, you know, I think you can take that with a grain of salt, but also I trust Martijn, so he knows what he's talking about. If this is your first time thinking about Flink, just know that there's a deep and sophisticated technology out there for you to explore. And while Kafka and Flink are impressive technologies on their own, I think the main takeaway from this keynote this morning is what happens when we start to use them together, right? How do they complement one another for a single use case where both streaming and processing are required? And we saw a little bit of how this will look in the future as we talked about 2PC. With 2PC on the horizon, immediate consistency is feasible, now more feasible than it ever has been before, for sources and sinks that you want to integrate with Kafka, including Flink. So I'm personally really excited to see what sort of use cases are going to be opened up, enabled, and made more simple by this flip and the sister kip. Well, we had a really jam-packed agenda for you today. We heard a lot about flips and kips that are going on, but I think everything that we heard about today is a testament to the power of community, right? As Ismael said, many hands make light work, and that is so true in open source. We wouldn't be here today without the tireless work of so many people contributing to these projects. And so I'd like to ask everybody to join me in a round of applause for all of the committers that helped to make these projects possible. Thank you to our Kafka committers, our Flink committers, for helping to implement these kips and flips and provide for us this technology that we use today for so many different use cases. And on a final note, a thing that I love about the data streaming community, and there are a lot of things that I love about the data streaming community, but I think the thing that I love most is that we like to get together, don't we? It's why we're here today. And it always feels, at least to me, like a big reunion. And so this is your chance to mark your calendars for next year, our 2024 events. We have Kafka Summit coming up in London. That'll take place March 19th and 20th. It's a little earlier than past years, so you definitely want to jot that down, make note of it. We also have Current coming back to Austin, Texas next year, September 17th and 18th. It'll be exciting. And also make note of the fact that our call for papers for Kafka Summit is going to open in the next month or so. So if you're looking to speak, and who wouldn't want to speak, just make sure that that's on your radar and that you apply. And with that, you know I'm going to see so many of you over the next year, either at these events, at speakers, attendees, or maybe at a meetup or two in your local community. So with that, get on out there and enjoy the rest of your Current. Thank you so much for being here.